Hello class 9, this is part 4 video of lesson water, and today we'll cover crystals and crystallization and hard water and soft water. We already came to know about the supersaturated solution, that is, when a saturated solution is heated and allowed to cool, the solution becomes unstable and we see something is formed. These are crystals. Now crystals is a homogeneous solid of definite geometrical shape, and how we form crystals is by using a process known as crystallization. This is carried out by using a technique of hot concentrated saturated solution. We cool it, we allow the solvent to evaporate, and we get crystals. At the end of the experiment, we observe that crystal formation taking place. Now we came to know that crystallization is a process by which the crystals of a substances are obtained from a hot saturated solution by cooling. Let's perform an experiment with this blue copper sulfate crystals. We take copper sulfate and heat it. As we heat it, we see the color changes into white powder. Now we add water to this white powder. We observe that it becomes blue. So what is happening? We have blue copper sulfate, we heat it and it changes into white powder. So why is copper sulfate blue in color? This is because there are water molecules which are loosely attached to copper sulfate crystals. Since these water molecules, that is 5H2O, are attached to copper sulfate crystals, we show it by a dot in between. Such crystals which have water of crystallization are known as hydrated crystals. Copper sulfate in this case is a hydrated crystals and are known as copper sulfate pentahydrate. So the reaction are, when blue hydrated copper sulfate are heated, it loses water molecules, leaving behind the white powder copper sulfate, which is known as anhydrous, which means water of crystallization from the crystals has been removed. Now if the reaction is reversed, we add water to anhydrous copper sulfate and cooled, it changes into blue hydrated copper sulfate crystals. So this is a reversible process, a reversible reaction, and we represent it into this way. Next is water of crystallization. The fixed amount of water that is loosely attached with crystals are known as water of crystallization. Example, 5 molecules of water is present in copper sulfate and are known as copper sulfate pentahydrate. 10 molecules of water are present in sodium sulfate and are known as sodium sulfate decahydrate. These are few examples of hydrated crystals which you can find it in your book. Now, it is not always necessary that a crystal has water of crystallization. Example, let's have a look. We heat a salt which does not have water of crystallization. Example, potassium nitrate. While heating potassium nitrate, it forms a compound in a molten state. A gas is released, which is tested by bringing a glowing splint. It rekindles the glowing splint. That means the gas is oxygen. In this reaction, potassium nitrate is heated to form potassium nitrite and oxygen gas is released. So we can see in this crystal there is no water of crystallization attached. Another type of crystals is which when exposed to air loses water of crystallization wholly or partly. For example, sodium sulfate decahydrate can lose 10 molecules of water completely or partly. Such crystals are known as efflorescent. Another type of crystals are when exposed to air, absorb moisture from air and dissolve in it and change its state. Such crystals are known as deliquescent crystals. Example is sodium hydroxide, sodium chloride, etc. Last type of crystals, when they are exposed to air, they absorb moisture but they do not dissolve and there is no change in state. Such crystals are known as hygroscopic crystals. Example, calcium oxide, sulfuric acid, etc. So there are three types of crystals. First, when crystals exposed to air, they loses water of crystallization partly or wholly, known as efflorescent. Some crystals when exposed to air absorb moisture and completely dissolve, change its state are known as deliquescent crystals. And lastly, some crystals when exposed to air absorb moisture but they do not dissolve and they do not change state are known as hygroscopic crystal. Next topic is hard water or soft water. Don't get confused. The term hard and soft is nothing to deal with softness or hardness of water. It is nothing to do with touch and feel of it. Well, actually, it is about chemical compounds dissolved in water. What are these chemical compounds dissolved in water? Let's see. When rainwater falls, it is naturally very soft. But as it makes way through drains, roads, grounds, etc., into the waterways, it picks up certain minerals in the waste, such as calcium and magnesium. This mineral changes softness into hardness. So, hard water contains high mineral content with calcium and magnesium, while soft water contains high sodium content with less concentration of calcium and magnesium. Now, how to check which one is hard water and soft water if we are provided a 2 glasses of water? Well, it's very simple. We add very few amount of soap on both the glasses of water, and the glass which have soft water in it will produce more foam, or we can say more lather in it, while the glass which have hard water in it will produce less amount of foam or lather as compared to soft water. Next is types of water hardness. There are 2 types of water hardness, that is temporary and permanent. Let's start with temporary. This hardness is due to presence of calcium hydrogen carbonate and magnesium hydrogen carbonate dissolved in water. And this hardness can easily removed by boiling. Like when calcium hydrogen carbonate is heated, it forms calcium carbonate in a solid form, carbon dioxide gas and water. And after that, if we filter it, we will get calcium free water. Similarly, when magnesium hydrogen carbonate is heated, it forms magnesium carbonate in solid form, carbon dioxide gas and water. And after that, if we filter it, we will get magnesium free water. Another type of hardness is permanent hardness. This hardness is due to the presence of calcium chloride, magnesium chloride, calcium sulfate, and magnesium sulfate dissolved in water. This type of hardness cannot be removed by boiling. There are few techniques to remove hardness, which is known as softening technique, which includes ion exchange method, using washing soda, reverse osmosis, and zeolite. Let's look at the reaction for using washing soda to remove permanent hardness. Like when calcium chloride reacts with washing soda, it forms calcium carbonate, which is insoluble, and we can easily filter it out to give sodium chloride and water solution, which is soft water. Another example is when magnesium sulfate reacts with washing soda, it forms magnesium carbonate, which is insoluble, and we can easily filter it out to give sodium sulfate and water solution, which is soft water. Now, advantages of hard water. Hard water contains minerals such as calcium, iron, which is good for bones and teeth and makes it stronger. Second is hard water does not dissolve lead and protect from lead poisoning. Third is it tastes better than soft water as it contains some minerals. The disadvantages of hard water are: first is it doesn't form lather easily, so it wastes a great deal of soap while washing. It tends to stain while washing and appears to gray on the surface for whatever we are washing. Number 3, it is not good for dyeing materials as it may form another compounds while mixing. Now, advantages of soft water: it forms lather very easily with soap, so it saves lots of soap while washing. Number 2 is it is compatible with dyeing. Number 3, it does not stain material while washing. Number 4, it does not form any unwanted layer or scales in container. And the disadvantages are it can easily lead to lead poisoning because it can easily dissolve lead. Number 2, since soft water do not contain any minerals, so it is tasteless and do not help in strengthening our bones and teeth. Thank you.